Okay, hello everyone. In this tutorial, I'll be doing the lower secondary examination for mathematics. It's a 2014 paper, and I was able to find it online. So I thought I might go through these questions and do it like one session at a time for each questions, and go really in depth for each of these questions, and really make you guys see, how beautiful math is, and you know so, without further ado, I'm going to go ahead and let's start with question one. And I'll definitely recommend you guys to do it on your own, and then later look at my working outs. Okay, so it says a letter is randomly chosen from the letters of the word similarity. What is the probability that the letter I will be chosen? Okay, this word probability, I'm going to write it down, and let's see. Probability. Okay, this word is just a fancy word of saying likelihood. You can also say likelihood. I don't know how to spell it, so I'm just gonna put it like that. And chance. What is the chance of you getting that? Okay. So probability talks about how likely or what is the chance of you that thing happening, that event. Okay. For instance, you getting all distinction on your examination. What's the probability? Okay, is it 100% likely to happen? Right? Is it? Are you certain that it's going to happen, or it's unlikely that it's never going to happen, or it might not? Okay, so I could give you some more examples, like, to be honest, we use probability, I would say, almost every day of our life. Okay, for instance, when you cross the road, like when you let's picture that's you, right, and this is the road, and that's the car. When you're trying to cross this road and get to the other side, you're calculating the probability or the chance that the chances that the car cannot hit you, right? So if the chances are high, that means that if the car driving towards you, to the road, if the chances is that it's not gonna hit you, then you are most likely to cross the road, right? If the car is most likely to hit you, then you refrain from crossing the road. Okay, so that's one of the examples, and you can think of countless, from putting spot bets to all sorts of things. Okay, you're like, okay, should I carry the umbrella or not? It's most likely to rain. Should I carry my umbrella with me? Okay, and is it maybe aesthetically, like you're trying to cut your hair and you're saying, what is the chances that I might look bad, and then things like that. What is the chances? Okay, it's a scale, and then you're trying to say what is the chances of you that thing happening. All right, now if we sort of look back at this question where it says what is the probability that letter I will be chosen, I want you to forget all about that, all the things that you think that you know about math. Okay, just forget it. Let's say a person who has never studied math, and you give him some bunch of letters like similarity. Okay, forget all you think, all that you know about math, numbers and whatnot, and just say you give this person who has no clue of math, okay, and you give him this bunch of letters, and you ask him that who will you place your bet on? I mean, not which letters are you most likely to place your bet on, or which letters are most likely to be chosen. The guy doesn't have to do math, okay? He'll just logically or reasonably just say, it's obvious that it's I, because there's three I's inside this sample. We call it this sample, okay? Or this different possibilities, okay? The chances of you getting an I is gonna be high, because it's gonna be it's obvious because there's more I's than there S, M, L, A, I, and all the other letters, okay? There's more I. So the chances of you getting I, or the probability that you get I, is higher, okay? Because there is more I than the other ones. Okay? But saying there is more and there is less is sort of vague, okay? There's no number. You cannot picture that thing, okay? So that's why mathematicians, they invented something called like a scale, right? So for instance, when you want to measure the temperature of the room, you get like a thermometer, right? If you want to see how long something is, you get a ruler. Well, to measure probability, mathematicians said, well, we can make a scale from like something like 0 to 1, okay? And if it's 0, that means that that thing is very low. It's not going to happen. It's not going to happen, okay? Not a chance. Never going to happen kind of thing. It's never going to happen. Never going to happen. I think this is a slang. You might want to say never going to. Okay. So you can think of this as like a measuring device that you can take to like a probability thing and say, oh, what if I take this scale from 0 to 1 and if I measure the probability, how likely is that? That's why they invented the scale, right? You can do it without numbers. You can definitely do probability without numbers. But numbers give you a very discrete value to the probability. So you can say, I can measure the probability from 0 to 1. And if it's close to 1, then it's most likely to happen. And if it's, on the 0, then it's less likely to happen. So how would you put a number to this probability? We know that I is the most likely thing to happen because there is more I. But what is it? How can we picture this in our head? Well, from a scale of 0 to 1, we can say 1 is it's going to happen, right? It's always going to happen. It's always going to happen. For instance, if I have like a sample of letter like I have 4 I's and I say, what is the probability of me getting an I from this box of letter I? It's obvious, right? The guy doesn't have to know math. It's going to say you'll always get I no matter what. So if you take this measuring device, which is like a scale from 0 to 1, and then if you put it to where this box where it contains all the I's, this thing will come and read it. It's going to read like 1 here because there's no way you can get pumpkins or cat or dog. You'll always get I because there's only I's inside, okay? So the chances of you getting an I is 100%. It's 1. So if you take this scale and put it there, it's going to give you 1. Right? So it gives you a picture, like a discrete picture of that probability, right? Instead of saying always going to happen, you can just say, yeah, it's from a scale from 0 to 1, it's 1, okay? It's always going to happen. So when we talk in numbers, it's easy for us to visualize and see the picture, okay? You can definitely do it without numbers, but I said, it's going to be like, yeah, it's less likely, it's most likely, and it might happen, might not happen. So you have these only words, and words are vague, okay? That's why I said mathematics is a language, because it's a very effective language, okay? It speaks very clearly and discreetly and not like ambiguous. So now back to where we were saying, okay, we can see that, okay, we have how many letters in total? Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay? We got 10 letters. So we can think of this as, having 10 segments, right? And then out of this 10, okay, this thing is like a whole, right? It's 10 of them. But out of this 10, you can only get how many I's? 1, 2, 3. So we have it 3 over 10, right? If you make all of this one become I, then it's going to be 10 over 10, which is just 1, right? If there is no I, it's going to be like 0 over 10, which is just 0. Like, it's not going to happen. If you have no I, there's no chance you're going to get an I. So putting it in fractional form, it helps you see the scale, like how probable that thing is going to happen. Okay? So if we look at this, our scale from 0 to 1, we have like 0.5 here, or also half, right? So how close is, 3 over 10 from this thing? Well, 3 over 10 is less than 0.5, right? Because 3 over 10 is something like 0.3, okay? So 3 over 10 is definitely less than half. So it's less than half. The probability is less than half, right? So even though you might place your bet on I, you might be a bit hesitant because it's not greater than half, right? It's less than a half. Um, this is going to be 0.25, but it's greater than 0.25, right? So it's somewhere between 0.25 and 0.5. So it's greater than 0.25, but it's less than 0.5. So someone might say the chances of me getting I is not like greater than half. So maybe I should think critically before placing a bet. But there's also a chance because it's greater than 0.5 or 0.25. So there's some chance that I might get 0.3. It's not like it's really close to zero, right? So you can so this scale 0 to 1 is just like I said, you can think of it just like a measuring device to measure the temperature or, you know, to measure the length. So this scale 0 to 1 is just a scale to measure the probability of getting that thing happening. So getting I has a chance of 3 over 10, right? And 3 over 10 is 0.3, and that sort of makes sense, right? Because out of these 10 different possibilities, you have 3 I's, so there's 3 out of 10 chances. So it's 0.3 from a scale to 0.1. For S, we'll just have 1 over 10, and I will have 1 over 10, M will have 1 over 10, and all of them will have 1 over 10 inside these different segments, right? And if you add them up, you will get 10 over 10, which is 1 whole. Okay, so it's like I has more parts in this, you can call it a chocolate bar or this segment. So I has more shares. So it's most definitely likely that you will get I than the others. Okay, so now you understand like probability, right? And why we use the scale from 0 to 1. And we didn't just decide to just pop that out of nowhere, but have put the numbers on the probability gives us more intuition, more insight, and helping us understand. Okay, so obviously 0.3 is the answer, and it doesn't really matter like the answer, like I said, but the understanding of how probability is and why it works it's the key thing. Then just calculating probability, like, okay, out of 10, so 3 over 10, right? Like, yeah, that's good, but you have to understand why is it 3 over 10. Okay, it's just, and then why you have to convert it to 0.3 to make the answer, like it's, and then understanding that why is important because it helps you have a foundational understanding of why the thing works. Okay, math is not there to torture you. It's a reasoning tool. That's why you gotta think through it, and yeah, it's just really reasoning at the end. Like I said, we did this without even like having someone who knows math, right? We just did it by just using our common sense and logic or reasoning. Okay, so that's it. I'll try to work on the next one, but that's for the first question, and I'll work on the next question in the next session. Okay, thank you.